My dear students, yesterday we have talked about the position time graph of a body which is moving with uniform speed or uniform velocity, right? Okay. So it is a straight line inclined to the time axis I said, right? How can you make a graph like this? Suppose this is the real situation in which a body is moving along the x-axis, starting its journey from 9 a.m. 9 a.m. is the time, the initial time. Your time starts at 9 a.m. That means your time is t is equal 0. T is equal 0 is actually 9 a.m. Then the time goes on increasing. 9.1 second, 2 seconds, 3 seconds, 4 seconds, 5 seconds, etc. It goes on. The body moves along the x-axis. After 9 a.m., that means that is t is equal to 0. Your time starts when you start the experiment. When you just open the eye and see, the body was at the point at the origin. You are standing at the origin, and that is equal to, that means body just starting. That is your time t is equal to 0. No matter whether it is any time, 9 a.m. or 10 a.m. or any a.m. or p.m., what time you start is the initial time t is equal to 0. Right? After 1 second, the body covers a distance of 5 meters along the x-axis. After 2 seconds, 10 meter. After 3 seconds, 15 meter, 20 meter, 25 meter, etc. 5 seconds, etc. That is actually drawn in a graph. So this is a real situation. You are standing in your house with a toy car, and toy car with a remote that you start exactly at 9 a.m. That is your time, 0 seconds, right? 0 time, and now go on watching, right? And you will see that after 1 second, it is 5 meter trace traveling. That data is collected from the real experiment and come to the paper. What paper? Graph paper. On the graph paper, x-axis, along the x-axis, time is marked, and along the y-axis, the position is marked, right? Then you will draw the what is called a position time graph, right? 0, 5, 10, 15, 20, 25. That will be a straight line inclined to the x-axis. Why? Because this body is moving with the equal displacements and equal intervals of time. It means its velocity remains constant. Right? Between 2 seconds and 1 second, what is the distance traveled? That is equal to 10 minus 5 is equal to 5. What is the velocity then? 5 divided by 2 minus 1 is equal to 1. That is, so 5 meter divided by 1 second is equal to 5 meter per second. Between 2 seconds and 3 seconds, what is the distance? The difference in distance? That is 15 and 10. 15 minus 10 is equal to again 5. And 3 minus 2 is equal to 1. Again 5 meters per second. Right? So that is why we say that this body in this case is moving with uniform velocity. Its velocity always remains a constant. As the body starts from the origin, the graph is also started from the origin. Right? Okay. This is the condition. Suppose the velocity can be obtained by taking C between 4 and 3 seconds, 2 perpendiculars are drawn, and 2 perpendiculars on the x-axis and y-axis. Then here these 2 points, that means you will make a small triangle there. Right? Between these 2 points, this is equal to 4 seconds minus 3 seconds. That is equal to dt. dt means change in time. And this time, within this time, the change in displacement is equal to 20 minus 15. That is equal to dx. So v is equal to tan theta is equal to dx by dt. dx by dt means change in position divided by change in time. In this graph, it is the slope. Slope is equal to tan theta. Tan theta is equal to differential coefficient of the position. Differential coefficient of the position means dx by dt. That is equal to slope. So by taking the slope of a PT graph, PT graph is position time graph, we are getting the velocity of the body. Suppose the body is not starting from the origin, then what happens? This is the origin. You are standing at this position. That time the body was here. That is t is equal to 0. Maybe the time at that time by your watch is equal to 9 a.m. 9 a.m. is t is equal to 0, and you are standing at this point and watching your seeing your watch. That time the time is 9 a.m. Okay, but the body starts from this point. When you are looking at the body, opening your eye and look at the body starts from this point. From which point the body is starting? From the origin. Away from the origin, there is a mark, 5 centimeter mark the body is traveling. That means at the zero time, the body is not from the origin, but it is away from the origin at a distance of 5. Right? Then the body goes on traveling. After 1 second, it is 10. After 2 seconds, it is 15. After 3 seconds, it is 20. And 4, 25, and 5, 30, etc. Right? That is marked here. At the zero time, the body has a 5-meter displacement. 5-meter position, the body was 5 meters away from the origin. So this data you will collect from the ground, and that is now drawn on a graph paper. How the PT graph is drawn? PT graph is drawn with the time along the x-axis and the position along the y-axis. Then also you are getting a straight line. Why it is a straight line? Because it is covering equal displacements in equal intervals of time. Difference between two consecutive time seconds is equal to the displacement. Suppose between 4 seconds and 3 seconds, difference in time is equal to 1 second. And what is the displacement? Displacement is equal to 25 minus 20 is equal to 5. 5 by 1 is equal to 5 meters per second. Between 5 seconds and 4 seconds, what is the difference in time is equal to 1 second. What is the displacement? That is equal to 30 minus 20 is equal to 5. Again, 5 meters per second. So this case also the body is traveling with the uniform velocity. This case also the body is traveling uniform velocity. The difference is that in this case the body is traveling from the foot of the observer. That means from the origin. But here away from the foot of the observer at a distance 5 meters away from that condition, this is the graph. Right? This is the position time graph. So position time graph is always position time graph is a straight line, always a straight line when the body is moving the uniform velocity, right? So 3 different conditions we have. So uniform velocity, this is positive, PT time graph for positive velocity. In positive velocity, what is called the slope is always positive. Slope means suppose this is the position time graph. Slope is always measured from the x-axis to the ground. In this case, this is the x-axis time axis, and we are moving in the anti-clockwise direction to measure the angle. So if a graph line is drawn and the slope is to be measured, and the angle is measured with respect to the time axis in the anti-clockwise direction, then the slope is positive. When the slope is positive, the velocity is also positive. So on the other hand, this is a case. This is a case means the body is traveling and you are standing at this position O. When you open your eye, the body was at the point 10 meters. You are standing at this position O. Zero position you are standing, the origin you are standing at. That time the body was at 10 meters away from you. Now the body is moving towards you. That means towards the origin it is moving. So at t is equal to 0, the position of the body was 10 meters. When t is equal to 1 second, the position is 8 meters. When the position is 2 seconds, then the position is 6 meters. 3 seconds, 4 meters. And 4 seconds, 2 meters. And 5 seconds, 0 meters. That is drawn here. Right? At the 0 time, its position was 10. At 1 second, its position is 8. At 2 seconds, its position is 6. Right? At 3 seconds, its position is 4. At 4 seconds, its position is 2. And at 5 seconds, its position is 0. A graph is made. That is also straight line. This is also uniform velocity, but negative velocity. Why negative velocity? Because if this is the condition, right? This is the condition. I'm drawing it again. So this is the position time graph, right? This is x-axis or the time axis, and this is the position axis. In this case, the angle is measured in the clockwise direction, as you see. In the clockwise direction, the angle is measured. So if a graph line whose slope is to be measured, if the angle made by the line with the x-axis measured in the clockwise direction, then the slope is negative. That is why the velocity of this body is negative, right? So this is about slope of the position time graph of a body, which is moving with uniform velocity or uniform speed. So this is the condition. Next we are coming to is relative velocity. What is relative velocity? Velocity of one body with respect to another body is called relative velocity. Suppose two bodies are moving with 2 different velocities. In this case, we will take a uniform velocities because we are discussing only uniform velocity now. After some time, we will discuss, on the next class, we will discuss the non-uniform velocity. But in this case, now we are discussing only uniform velocity. Bodies moving with a uniform velocity. Two bodies are moving in uniform velocities. Then velocity of one body with respect to the other body is called a relative velocity of one body with respect to the other. Right? That I am going to explain it today. Relative velocity. Suppose two bodies are moving in two straight lines. In two straight lines parallel to each other. One body has a velocity VA. Other body has a velocity VB. Then relative velocity of body A with respect to B is given by VAB. That is equal to VA minus VB. This is the general expression for relative velocity. One body is moving with a uniform velocity VA. Other body is moving with a uniform velocity VB. Right? Then relative velocity of body 1 A with respect to the velocity of B is equal to VAB is equal to VA minus B. Similarly, relative velocity of B with respect to A is given by VBA. VBA is equal to VB minus VA. This is the condition. That means velocity of one body is added with the negative velocity of the other. We will get the relative velocity of one body with respect to the other body, right? So this is about relative velocity. And suppose that two bodies are moving in two straight lines, right? Straight lines like this. Okay, one body, suppose this body is A, and this has its position at this is the origin, right? This is the origin. So the body's general condition is not actually starting from the origin only, but away from the origin. That only we have to understand. Yeah. So this is the situation. This is one body is traveling along this direction, right? Suppose this is the origin, and one body number 1 is traveling from this point. The position of the body along the x-axis when t is equal to 0, t is equal to 0 is x10. x10. After t seconds, suppose the body reaches at this point, that is equal to x1t. x1t. So this is first body traveling along this direction, body number 1. Right? This is over. You are standing at this position. Origin is your position, right? When you are standing at the origin, the body was at a distance away from the origin. That distance is equal to x10. What is x10? Position of the first body when time is 0 seconds. When time is t, the position of the first body is equal to x2t. Am I correct? Yeah. Another body is also traveling in the same straight line or in a parallel line. This is 0 time. This is the position of the body. That is x20. Bit near to the origin, right? x20. x20, what is x20? That is the position of the body when time is initial time. That means time t is equal to 0. After t seconds, that reaches to the point, this one, that is equal to, that is x2t we can mention. Okay. Both the bodies, we will assume that they are moving in the same direction, and also the displacements of these bodies for unit time is same. That means both these bodies are moving with the uniform velocities. So for the first body, I can write xt is equal to x10 plus v1 into t. v1 into t, because this body has a velocity v1 and this body has a velocity v2. v1 means all along the journey, the first body keep